Good morning. We are going to have an awesome session here in a little bit by Matt Benio. Every now and then we get a session here that sort of peels back the curtain a little bit, and I think this is going to be one of them. You're in for a bit of a treat. Bit of a reminder, we are doing Q&A through the app this year, so in the upper left corner, go into the Q&A section, submit your questions online, and if you see questions you like, upvote them. Makes it a little easier for me to see which ones to read off. So, without further ado, Matt Benio.
Thank you. So, my name is Matt Benio. I am a macOS threat researcher at Jamf. I'm part of the Jamf Threat Labs, and Jamf Threat Labs encompasses a lot of different things. I'm on a team that's specifically focused on macOS malware, intrusion techniques, and finding ways to detect those things and prevent them from happening on computers that are running Jamf Protect. So the title of this talk is The Art of Cryptojacking. Unfortunately, maybe for someone in the audience, it's not necessarily a tutorial on how to make passive income using Jamf Pro to run crypto miners on your organizational computers. Although maybe some nuggets of how that one might do that might be in this presentation. That's definitely not the intention. So if you need to leave, that's fine. So the way that security products get marketed, it's pretty easy to start to think of threat research as this, or anything adjacent to hacking as this spy versus spy, kind of cloak and dagger, superpower versus nation state type of stuff. And there is definitely some of that. One of my colleagues, someone on my team, Firdaus Seljuki, he's got a session a little later today called, I can't remember the title off the top of my head, I'm blanking, but it's about nation state malware, and that's in the title. So if you search for that, definitely check that out. We uncovered some really cool North Korean malware, and he goes deep on this. This is a little bit different. This is what I would consider like a dumpster dive, because the other side of it is like this really greasy, scammy, scumbag type of stuff, and these are their stories. So we uncovered this cryptojacking botnet, and we wrote a blog post about it, and it got picked up by the tech media. And I think it got picked up just because it's kind of a funny, interesting story. So, and it's something that I think a lot of people can relate to and wrap their heads around. And it all started with an alert that we got based on the threat prevention feature that's in Jamf Protect. So let me just give you a little bit of background on threat prevention and how it works, just as context to tell this story. So Jamf Protect, it operates as a system extension. It's using Apple's endpoint security API to get visibility into the kernel. And the reason that's valuable is because it allows us to operate in user space and get all that visibility we would have if we were a kernel extension, but we don't have any of the headache of having to maintain and build a kernel extension. So this API grants us some authority to kind of intervene. When a process wants to run, it'll actually check in with us, the system extension, the kernel will, and say like, hey, should this process run? Here's some information about what it wants to do. So for example, a process wants to be launched. The API gives us data about that event. We determine yay or nay, and then we release it if it goes. In the case where we find something that we don't like, same idea. Process wants to run, we get data about it, we make the determination this should not run, and then we say no, and it doesn't get to run. So we're not killing a process, we're actually just preventing it from being even run. But obviously Apple is protective of their user experience, so they're only going to give us a pretty small window to be able to act on these events. So we use a few different methods that have to be very fast to determine whether something should be able to run in the moment. And so let me just talk about what those are really quickly. So the first one is a file hash. So for anyone who's not familiar, a file hash is kind of like a digital fingerprint for a file. So you probably recognize the idea that any computer file or an executable is really just a bunch of zeros and ones. So if we take those zeros and ones, run them through a mathematical equation, each 0 and 1 is going to change what the hash of that file is, which is cool because if you have two files that have the same hash, you can be assured that they are identical files. But that goes in both directions. If we add 1 0 to the end of a file, suddenly we have a completely different hash. So it's kind of a first line of defense. We can say, hey, if a file has this hash, don't let it run. But that doesn't account for any changes that can be made to that file. So that's the first thing that we're able to do. The other thing we do is around the idea of signing information or team IDs. So if you're a developer, anyone who's ever used Xcode, when you're done with your project, the idea is that you want to sign it to be able to run on other computers. So you need a developer ID that costs $100, and you kind of need that for distribution. And so this is kind of a nice obstacle for malicious actors. They at least have to spend the $100 to sign it, because at this point, it's gotten really hard to run unsigned code on macOS. So you've got your executable. You can check the code signing information using this code signing utility. You'd see the team ID that's there. We can just say, hey, if you see anything signed by this team ID, don't let it run. The last one is kind of the most interesting one, and this is the idea of Yara rules. So Yara is an open source way of detecting things like malware, and it's used all over the place. And Yara rules are surprisingly dynamic, because what it allows us to do is to detect on sequences of hexadecimal bytes or strings. So what the heck am I talking about? Well, we talked about the zeros and ones. Those zeros and ones can be represented in base 16. And we can look at a file and say, hey, if there's this sequence of hexadecimal characters in a file, don't let it run. So if someone wanted to get around this, they would have to know exactly which sequence we are detecting on. But we also have to know, hey, this is going to be something that won't show up in legitimate software. So there's some work that goes into that. Another thing that's cool about hexadecimal is that there's a range of these bytes, of these numbers essentially, that represent like what we would think of as printable characters, so things that are readable, and those are called strings. So when you're compiling a file, you're probably going to have things like error messages or function names that end up hard-coded in the executable, and they can be read, and we can use these as a basis for making a rule. So we can take a utility like the strings utility, dump out the strings, pinpoint stuff that looks specific to this potential malware, and then build a rule around that to say, like, okay, if you see these 7 strings, and then also the file is under 7 megabytes, that's a hit, don't let it run. So that's how we use Yara rules. And Yara rules are used already. It's built into macOS because it's essentially the thing that's powering Protect. You can go to this file path right here and open it up, and you can literally read in plain text all of the Yara rules that are in there, which is kind of cool if you're interested in this sort of thing. It's also kind of cool if you're a malware author, because obviously if the current version of macOS is going to catch your malware, and if it does, you can just go look and see which strings it's detecting on. So when people ask about like, well, I got Protect, isn't that good enough? I mean, this is one of the things that you have to kind of think about, is that it's something that can be worked around. So those are the 3 main areas that we're focused on: the file hashes, the team IDs, and the Yara rules. But since we are an enterprise application, we're able to be a little bit more heavy-handed than Apple is. So there are things that Apple can't just block across the board that don't necessarily make sense to see in an enterprise environment. For example, things related to crypto mining. So let's talk about crypto mining for a little bit. So the basic idea in crypto mining is that you are volunteering compute resources to essentially solve a complex Sudoku puzzle, and in exchange, you solve that puzzle, it gets added to the blockchain, and you get a reward for it. Pretty cool. But it's not just a simple money printer, because there's a lot of overhead to it. So you have to buy these expensive rigs, and you have to think about the electricity that now you're running these computers all the time. That's going to eat into your profits. And on top of that, you've got just the price of crypto is going down over time, up and down. It's really volatile. So it's kind of a headache. One way you can avoid a lot of these drawbacks is to find a way to do it without having to use your computer or electricity. And so this is where it all kind of comes together. So there is a command line tool that you can run on a Mac called xmrig that mines cryptocurrency. And if anyone has kind of looked into this sort of thing, you're not going to be making a lot of money running xmrig on your individual Mac. However, you scale it up, now you're in business. So we felt like this is a pretty good thing to look for. Let's just make a Yara rule based on this utility and see what comes back. So one day, we get an alert. XMRig has been detected. Okay, not totally surprising, but let's look into it. The path where it was running was Final Cut Pro. Curious, okay. Final Cut Pro, for anyone who doesn't know, it's an Apple application. It's a bit curious. And at the time, we were at the beginning, early days of the techpocalypse, but it didn't seem like it had gotten bad enough that Apple would be stooping so low that they're trying to mine crypto on people that are buying Final Cut from them. So we decided to examine the specific hash. We looked at it, we compared it. I had a legit copy of Final Cut Pro, and it's not the same, so not a huge surprise there. So we take that hash, and the normal thing we would do in this situation, go over to VirusTotal, plug it in there, and womp womp, no matches found. So this is something that no one else had really seen before. That could mean a lot of things. It could mean we found something really exciting. Maybe this is something that's just dynamically generated every time, so you're not going to see another copy of it elsewhere. So if you don't have the sample in our boat, like there's not much else you can do. So we start scratching our heads and we're saying, okay, well, it came from Final Cut. Obviously, it's not the real Final Cut, which means it's probably a pirated version of Final Cut. So let's go looking for it. So if I was going to find an illegal copy of software, like the Pirate Bay, I guess, was what I thought. It had been a while. It was kind of shocking to see that it's like still a thing, that people still torrent stuff, but they do. So we went to the Pirate Bay, looked for Final Cut Pro, downloaded the most recent upload of it, had a decent number of people seeding it, downloaded it, checked it out, copied it over, speed through here. And when I launched it, I kind of panicked because look at the bottom here. All these little binaries started launching, and I was like, whoa, 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 what just happened to my computer? But it actually turns out that's a normal part of Final Cut. So everything looked good. It's a real version of Final Cut. And so I thought, okay, well, maybe this isn't it. But so I go start looking at the actual application bundle, application, Final Cut Pro, contents, look at the actual executable. Everything in the structure looks normal and right. The code signing was wrong. That was a big clue, but something is off here. And so I looked at this executable, and the first thing that we noticed was that it's 11.9 megabytes. The actual executable for Final Cut Pro is 3.9. So there is something going on under the hood of this thing. Probably malware, obviously. So the crazy thing then is that we looked at the hash, compared it to the one in the alert, and it's the same one. So like I want to say we spent months looking for it, but it was literally on the first try we found what we were looking for. We found this this malware, this crypto mining malware being spread all over. So we take the executable, use that strings utility we talked about. What's going on under the hood of this thing? Big wall of text happens. We start scrolling up from the bottom. First thing we notice is a very complex bash script. So before we started untangling any of that, we kept scrolling. And what else did we notice? This crazy wall of text. The heck is that? So this is something called Base64, if you've never seen it. It's just a text encoding. It's kind of like email uses it to encode images. I don't know if it still does, but that's kind of where it started. And it's definitely not military-grade encryption, but it is like what a lot of kind of junky malware will do to avoid its strings being read. Just kind of similar to like pig Latin, where it's just like, yes, you're probably going to be able to confuse your children, but like anyone else can very easily just run a command on this to turn it back. So this is a really good place for us to start. So we started pulling this whole thing apart. And what we found was that the way that this thing works is you've got your little Trojanized Final Cut Pro, and you launch it, and that script actually reaches into itself and pulls out these two other blobs. So within the base64 was more base64, and the first blob decodes into the actual legit Final Cut Pro and is launched. So if you're the user, everything looks good. Final Cut Pro is running. But what about that other blob? So that other blob, decode that, and you get something called I2PD. So I2PD, just like a quick overview, it's basically a daemon that makes your computer a node in the dark web. So it's not Tor, but it's very similar. So it's part of this thing called the Invisible Internet Project. And the way that it works is a bunch of people have this thing installed on their computer. And it allows for anonymizing traffic and communication between these different nodes. So let's pretend these are houses. Purple house wants to send a message to the green house. And so what it will do is it will take the thing it wants to send, like xmrig, for example, lock it with a green key, put that in an envelope, lock that with a yellow key, put that in an envelope, lock that with a pink key, put that in an envelope, lock that with a blue key, and so on. And then the last house that it gets put into, or the last envelope, gets forwarded to that location. Only the red house has the red key to open this envelope. It opens it. Blue house forwards it to the blue house. Blue house only has the blue key, and so on. And at some point in this animation, we'll skip ahead mercifully. Thank you. And so all the way to the greenhouse. So if this gets intercepted in any way, there's no way to really untangle it unless you have the encryption key to unlock your node in it. So it's a way to just silently send data that can't be tracked. So this is what it looks like. You send it, it routes through, it kind of arbitrarily picks what path it's going to take, and then the channel that's going back actually takes a totally different channel. And so this is a really great way to obscure traffic. So of course, these aren't houses, they're computers. And so the way that this works in our case is that this daemon reaches out to the attacker server, and the attacker server sends back xmrig to be installed on the device. And then suddenly it starts sending blockchain pieces for the computer to solve. Once the computer solves it, it sends it back over I2P. So let's talk a little bit about what's being mined with xmrig. So it's not Bitcoin, it's not Litecoin, Dogecoin, any of these ones you've heard of probably, and some of you may have heard of Monero. But Monero is really specific because it has a very specific design feature, which is that it's not meant to work easily on what they call ASICs. So these big GPU rigs that people are buying to do crypto mining, this is designed to work on phones, computers, whatever. And it's kind of branded to be this like democratization, but any one person doing this is going to make fractions of pennies. So like it's really hard to imagine a scenario where a botnet is not involved in producing money this way. So the way that Monero works is same idea, you have the blockchain, and it gets distributed across a bunch of computers. The computers each solve their micro piece of it. They submit their work back, and it's reassembled. And then whoever is running this kind of pool then collects the money for it. So on the grand scale, you have these pools. So these are, essentially you can think of them as botnets. Maybe they're malicious, maybe they're not, but there are these things. So at the grand scale, these blocks are being sent out, being distributed among the groups. They do the work, they send it back. If they get it done in time, there's a time aspect to it, then they get the reward. So in our specific situation, presumably this attacker is running their own pool, and they get the blockchain information. They have, via Pirate Bay, all these people who have been duped into downloading Final Cut Pro, all of these nodes in this I2P, and they've used that to then install xmrig on all these different machines, and then they can send out the different pieces. And this thing runs essentially until a person restarts their computer or relaunches Final Cut Pro, and they're then able to collect the money for it. So this also led to a kind of natural next question, which is like, who uploaded this? Who's doing this? So we went back to the Pirate Bay, and the Pirate Bay has a great feature, which is you can just look at the username of the person who downloaded it, or who uploaded it, clicked on that. His name was WTF is that, and a bunch of numbers, which I thought was humorous. So we click on this name, and this person has been uploading these torrents since like 2019. And much probably to my ISP's chagrin, we downloaded like we downloaded all of them. It's like 30 or 50 of these. And like, it honestly didn't, it wasn't until I got to the end that I realized like, oh, I might lose my internet connection over this. So Well, yeah, exactly. No, I didn't. I was being lazy, following the rabbit hole. So we go through this dumpster dive. We analyze all of them, and it turns out like literally all of them are infected. I mean, that shouldn't be surprising, but literally all of them are infected in this way. So that allowed us a unique opportunity that's not normal for this type of research, which is we had like a whole evolution history of this malware, starting with 2019. So in 2019, this is when the first sample was essentially uploaded to this. It shows up on Pirate Bay. And it was a little more primitive. So you had your application bundle, and they just had these malicious, the XMRig and the other pieces were just hanging out, and they used like the, the thing where you can put a period in the name of a file to hide it, just hiding there. So you could use a keyboard shortcut and show it. I know if I was making this malware, like I'd be very anxious about having used that method, even though people are unlikely to, but people that use torrents these days are trying to do at least some due diligence on looking into this stuff. So pretty quickly, they evolve it. The first version also used like a launch daemon, so a little bit greedy. They wanted this thing to be running at all times. And to get that thing installed, they gave you this prompt that said, Final Cut Pro wants to make changes. That's all it said. And you put your password in, that then gave it the authority to install itself as a launch daemon that would always be running. But they start getting a little more savvy. In the later phases, so we're still in kind of the evolution one, they went, I think it was maybe 6 to 8 months before any of these even ever got uploaded to VirusTotal, because we can also see the history. Like we went through each one, looked to see like when was this first uploaded, when was this first detected as malicious, and this stuff was going, basically was first picked up like 8 months in. Within several months, a couple months after that, most of the vendors have caught on and are successfully saying like this thing can't run. So they ditch the launch agent. That probably makes it, they're probably trying to figure out like, what do I need to do? Like, how are they picking me up? I'm going to ditch the launch agent, start throwing this stuff out of the airplane to avoid getting caught. And then they decide, you know what, this isn't working. Like, let's rethink this. So we start to see a generation 2 that comes forward. So generation 2 shows up in April 2021. And suddenly it's undetected again. And they start to use a little bit of the base64 encoding. They're still hiding files a little bit, but they're getting a little bit more careful. And this is around the time that we at Jamf Threat Labs start realizing like, we should start like looking to see if XMRig is running on some of these machines. And so that's when we first start putting our feelers out. Oh, sorry, push the back button. So then a Gen 3 comes out, and the Gen 3 has some pretty interesting features. So we talked about this earlier. There was this big script that kind of is the one that's orchestrating all of these unzippings and things like that, and even pulling down the XMRig. So really hard to read this, but put in some line breaks, it becomes a little bit easier. There was a feature in this malware that is like one of my favorite parts of this story. So this here, this pgrep activity monitor, we can break this down a little bit and simplify it. So the basic idea is that this malware has a script that's running on a continuous loop. So in a continuous loop, go ahead and see if activity monitor is running, right? Is activity monitor open? If not, carry on. If it is open, then like kill. Like, and so it's checking this like every few seconds and doing this over and over. Sorry, every 1 second. So what this looks like essentially is, okay, this is like a simulation. So it's like, okay, I'm running, I'm doing bad stuff, I'm doing mining, and then the user is like, my CPU and fans are on, what's going on? I open Activity Monitor. As soon as Activity Monitor opens, it kills, and you see how long it takes Activity Monitor to load. Like by the time it fully loads, this thing is long gone. And so just like some really little sneaky techniques, and it's interesting to like pull this stuff apart and start to think about the person who is kind of coming up with these ideas. So going back to our malware history timeline, they start to move totally away from Gen 2. They get fully into the Gen 3. And that was the one that we initially found, the one where it's just one single executable. Everything looks normal until you start to look at the strings, and it's all that base 64. And at this point in Gen 3, it's like people had already kind of written about the first generation of it and like, okay, yeah, we got this thing under control. Like this thing has been shut down, not realizing that it had already pivoted. And by the time they were writing about Gen 1, Gen 3 was already out. It's kind of crazy how this stuff works, the cat and mouse of it. So we detect this for the first time. This is when we first find the final cut. We start pulling it apart. And we do some research around it, obviously. And then, like, this actually needs to be updated, but like, there's still, like, to this day, if a Logic Pro or a Final Cut update comes out, like within a day or two, this person has a new version of this thing up and running. So we took this all to Apple. We published our blog. Before that, we took it to Apple. Apple actually did an X Protect update. So, you know, they're doing it a few times a year. One of those was for this. And we got, you know, there was the update, Eclectic Light Company, Howard Oakley is awesome, covering all this stuff. But it was fun to see the update of the thing that we, you know, did and have that get put in there. So we published our blog, and the rest is history. And again, this is a bit of a dumpster dive. It was a fun rabbit hole to go down, and hopefully you see like the passion and interest we have in pursuing these rabbit holes. And you might think like, okay, someone is, you know, mining crypto on a work machine. Like, it's not the end of the world. But at the end of the day, like, your company is investing resources in Apple products, which they're probably doing because people like them. People like them because they have good performance. And to have something like this freeloading on your resources just slows things down. It hurts battery performance and things like that. So also, like, having a dark web node on a work computer that could be used for other purposes is also highly problematic. There's also theoretical ideas that there are these more advanced gangs that are using these like dumpster divey schemes to just get on endpoints. And if someone finds it, it's like, oh, it's just cryptojacking. But could be used potentially for other nefarious purposes because all the machinery is essentially there to do something else. So I want to also direct you to a couple of my colleagues' sessions. We've got one, Jaron Bradley. Jaron, you're in here, aren't you? No? He left. All right, well. He's got one for a tool he built called Sprite Tree that's really cool for doing these types of investigations. He and Maggie will be presenting on that, so look for that one. And then Firdaus Seljuki will be doing the one on nation-state malware. Thank you.
Awesome. Give it up for Matt Benio and the rest of the Threat Labs team. I'm going to take a quick moment to plug one more session.
Yes.
Tomorrow morning in this room, we've got sort of a sister presentation.
Yeah.
Maggie and I built sort of the other side of the coin and how Jamf Protect protects you as an admin and sort of giving the admin's perspective on being the target of an attack like this. We've got a couple questions and also some kudos. Ray from JPL says, kind of brilliant. Victims wanting Final Cut may have strong systems and might not notice the resource drain and assume that it's just part of the rendering process.
Yeah, I didn't mention that, but yeah, all the software that was being targeted was like Photoshop, Final Cut, Logic, like any of this stuff that's CPU intensive where someone's fan turning on their computer like might make sense in the context.
Yeah, we've got an anonymous question here, which is something that was on my mind as well as you were talking about possibly losing your internet from doing all of this.
Yes.
Is there a DMCA exemption for security researchers downloading pirated software? So DMCA being like copyright stuff. Are the internet police going to show up and say, you just admitted on the internet and a public stage?
It's a great question. I don't know, and I probably should know the specifics. However, in this case, and I did think about it early on, my thought was, okay, well, like Jamf, like we have a close relationship with Apple. Their product is being used to, you know, do this shady thing that now they're getting sucked into. I own a copy of Final Cut Pro that I paid for. So I knew that eventually we would be giving them this information. So like they would be the ones we would have to answer to.
They're probably not going to update Protect to protect against this and then sue you for helping them find it.
Yes, and if they wanted to say if Jamf wants to continue its relationship with Apple, they need to fire Matt Benio. Like they clearly had that power to do that. So I felt like I had my bases covered.
Yeah. So we got a question here. How did they bypass some of the default macOS security and signed apps? Did the pirated app ask to right-click to open to bypass? Was it signed? Things like that.
Yeah, there was some of that. And we see this in a lot of these torrents. And I will say this: it's almost impossible to run this hijacked application on current iterations. I think even when it switched to Monterey, it got much harder because I think these were signed ad hoc. It got much harder to run this at all in Monterey, and they were doing some other weird stuff that it was breaking. So yeah, if I recall correctly, it required, and it even had instructions where it would say like, right-click to open, or sometimes they'll say if that doesn't work, just disable SIP, which I think is a hilarious thing to put in.
Jaron and Maggie's presentation actually shows some of the end-user side of that, and they show like a DMG with an example of how it was formatted to show like, oh, just right-click here and do this to bypass Gatekeeper.
Yes, I don't think it applied in this specific one, but one that we see all the time that we've created a Yara rule for is that a lot of these torrents will have you open up the disk image and there's a button that says open Gatekeeper friendly. And all it is like you hit the script and it just like strips all the quarantine attributes off of the file and like opens it for you. It's like, okay, that's one way to do it. So if you have Jamf Protect, and you'd be amazed how often that one triggers in people's environments. So there's a lot of people torrenting on work computers, which is kind of crazy.
Another kudos here. As someone who's just helping with a conference and has zero understanding beyond a basic understanding of what Jamf and you do in general, your presentation was absolutely stellar and super fascinating. This was amazing to learn all about. And I couldn't agree more.
Okay, yeah. Thank you very much.
I know quite a bit about this stuff, and I think it was amazing.
Thank you. I appreciate that.
That's all the online questions. We got about 15 more minutes here, I think, if anybody in person has something, or you can submit it through the app. Yeah.
Can you help us push that to our work computers?
Yeah, right? Yeah.
So the question was, how do I push this to my work computer to make a little extra money?
I mean, I showed you GitHub is where you can get the XMReg utility and chain policies. You know the rest.
You said at the start of your presentation that yours was not a how-to guide on how to do this. Right. I'll say that ours tomorrow morning kind of is, but it's also hopefully a guide on why you absolutely should not do that.
Yeah, and if you're going to do that, make sure that you're also the admin of Jamf Protect because it will catch you doing it.
Yeah, so. You'll catch yourself.
Oh, sorry.
Quick question. Is there any plans to incorporate custom Yara rule support within threat prevention?
So the question was, is there plans to put custom Yara rule support into threat prevention?
It's definitely been discussed, and it's come up many times. I think the biggest limitation is that it's hard to do Yara performantly because you can do things like regex and there's all these things that you could be holding up the show. And I mean, to be totally honest, like part of our psychology is like, okay, well, if someone is using bad Yara rules and then now suddenly Protect has bad performance, like we're left holding the bag. So like, I think that's the mental block that prevents us from supporting that potentially. But it could be something that becomes like some type of premium feature that is offered to a certain type of customer. But I think that would be amazing if you could just feed in your own Yara rules.
Organization has a full-blown security operations center, and there's occasionally situations where
right.
to be able to deploy those is a very natural step, and then it's like the Apple ecosystem that we have.
Totally, yeah. There's not an easy way to do it. So yeah, it's something I've brought it up many times, and we'll keep thinking of ways that we could do it in a way that pleases everybody, but it's definitely something that has been discussed.
So to close the loop on that one really quick, Jamf Protect has threat prevention as a feature, which Matt explained in detail. There are rules that our Threat Labs team makes for threat prevention, but we do also have the ability for you, the admin, to say, I don't like this specific signing information. I don't like this specific file hash. I want to block that, even though the Threat Labs team doesn't think it's worth blocking. And the question was basically, can we do that with Yara someday?
Yeah, so remember those 3 things that we're using to determine, 2 of them you can add to. You can add team IDs that you want to be blocked, and you can add hashes you want to be blocked. But as of now, you can't put in your own Yara rules. But maybe someday, we'll see.
Yeah, so we got a question following up on the evasion tactics, defense evasion. How does a design like this work in the context of malware delivered by MDM? Thinking open source repo to auto package pipeline, whose agents don't raise flags for services like Gatekeeper.
I mean, yeah, that's a good question. And like the thing that I think keeps us at Jamf up a lot is that like if you can compromise at the MDM level, like the world is your playground at that point. And so it's something that we think about a lot in terms of we have certain tamper-proofing detections that we're looking at for Protect itself. There's also things with Jamf Pro that we detect on that imply some type of malicious use case. But yeah, there wouldn't be a way. Like it's who watches the watchman, really, that type of a problem.
Yeah, awesome. I saw a couple other hands out here. We're done on the app again. Yeah.
So I think a couple of things that you talked about are very interesting, right? From like all the 3 things you look for hash, you look for Yara rules and all of that. That helps in big scheme of things, especially when nation state actors, malware families, you will see
Yes.
strings, you will see some hash matches. How about net new evolving threats, right? So
Yes.
So how should the customers protect themselves?
Absolutely. So
I'm just going to recap the
Please
question
do,
real quick. So the question was basically like, this all looks great for known stuff, but what about new and evolving software? Like it's an arms race. How do we win that arms race and stay ahead of the game?
Very good question, and it's a bit of a design flaw in this presentation in itself because it's focused on the threat prevention aspect, which is kind of our first line of defense, but it is not the limitation of what Jamf Protect does on its own. So one of the things that we do, and kind of the crown jewel feature of it, like when Jamf Protect first launched, was this idea of behavioral detections. So we can take things, for example, like if something's looking for activity monitor, if activity monitor is open, then kill this process. That can be extracted away into a behavioral detection. So if anything else attempts to do that, so you could say, if something checks for activity monitor and then it kills something, like theoretically, like that could be how a behavioral detection would work. And so a lot of what we do is, yes, block it by the file hash, yes, extract it away to strings, but then like let's abstract away like what are the tactics that this malware is using, because those tactics get reused all the time. Even in sophisticated malware, we see them using old tactics. And so if we can detect on the tactic, then suddenly you can pick up, malware that hasn't been written yet.
Yeah, I'll sound like a broken record here real quick and say our session tomorrow morning, we talk a lot about that, and we talk about using some of those behavior-based detections to block the kill chain even earlier, and we use the Pro and Protect integration. There's some integrations between Pro and Protect, where if a behavior-based detection goes off, you can like run a Pro policy, and we put together some remediation around behavior-based detections in that presentation. Yeah.
I'll give you one more opportunity to plug based on where you're good. So when you learn these attacks from one side of a customer, how do you propagate that every other customer is now aware and protected, because you already saw this in the one?
Yeah, so the question was, okay, so we see a behavior-based detection, we see something new and original, one customer is experiencing it. How does that make its way into the product to make sure everybody's protected? And I would say that's basically Matt and his team's job.
That's the nature of our work, yeah. So it's putting out things, tripwires to catch stuff, and then taking what comes back and putting that out into new detections, whether that be behavioral, static, or otherwise. And that's just kind of the nature of it. I had something else I was going to say, but I forgot.
Cool, I saw another hand anyway, yeah.
by trying to use inter-process communication requests to have essentially their malware look for standard methods that native binaries and good apps use to execute malicious functions.
Totally.
Yeah, so okay, I'll just repeat the question. For the folks that are online, and thank you for joining us online, by the way, they can't hear unless I repeat it, or you repeat it. So the question was basically from the perspective of defense evasion for this particular attack that you pointed out, are there better ways that they could have hidden themselves through things like XPC and stuff like that?
Yeah, certainly. I mean, this was not the most sophisticated attack. Obviously, they did a lot of things to obscure what they were doing to make it kind of a headache to untangle what they're doing. But a lot of it was just written out there in plain, Bash script. And there are ways to live off the land to, do things that would have been a little less obvious. But I think for these situations, it's just kind of like, if it works, do it. They put out that very primitive version. Obviously, the fact that they're still doing it 4 years later, tells me that they have a lot of spread on this. And obviously, certain pathways have gotten closed off as other vendors and stuff picked it up. But, we don't really have a way to quantify how many endpoints this is operating on and what amount of money that equates to. But again, the fact that it's still going on 4 years later tells me that there's some incentive to go through the work and risk of putting that out there.
Yeah, I think just like in normal engineering that is not malicious,
Yes.
Sometimes good enough is good enough.
Yeah,
and
it's an MVP.
If
Yeah.
you're, there was one more in the third row over here.
This has become more of a commiseration thing, so that people have been asking similar questions. But the challenge that I'm facing it sometimes is convincing my management the need for implementing a Mac-centric solution. So right now we have Sentinel-1 as our overreaching element.
Yeah.
And they use Jamf, which was kind of neat. I was very happy. I taught them Jamf parameters when deploying their Sentinel-1.
Cool, yeah.
But the challenge a lot of times is that there is a concern in our engineering groups about other solutions that different teams are using to make certain things happen, and getting caught up in some of this stuff.
Yeah.
We have a process where one of the vendors' Mac apps was written so horribly, it was eating up like a massive amount of CPU power, and their solution was a launch daemon that noticed excessive CPU power and killed the process and restarted it, and it got flagged
Right.
in one of our systems.
Right.
So that's more, like I said, more of a commiseration than anything else.
Yeah, no, it's tough. I mean, that's the thing that's funny for us, because a lot of times when our detections come back, it's like, oh, this is something an admin is doing. This is like some jury-rigged thing of and they signed it com.apple because they didn't know what else to do. And it's a tricky thing to separate. But I do think there is a big value in having something that's Apple-centric, because it just takes so much mental RAM to think through all those little things. And if your attention is split across all these platforms, you just can't do it properly. Most organizations can't, the reason we probably are the ones that found it is because we didn't have anything better to do than to dumpster dive on specific macOS stuff. It's just it to be, there's the Windows stuff is crazy, but that doesn't mean that there's not stuff that needs to be explored. It's just no one has the resources to do it.
This is a weird conversation you want to have with your boss. It's like, oh, I caught this because I was sword fighting?
Yeah.
I was waiting to see
yeah.
Jaren face palming in the back of the room. Matt's boss is in the back, and Matt's talking about how he's bored at work.
Yes. Yes.
So just to recap that, we were talking about basically other security solutions out there that may not be Apple first, Apple best, as Jamf is, and the pain that can come from that. And I guess in response, I would say, have your boss talk to the Jamf salespeople about Jamf Protect, because we are Apple first, Apple best. And I work on the Protect development team, and I have never worked with a group of people that are more passionate about keeping that Apple experience just as high quality as possible and making a product that's not going to get in your way and it's going to allow you to be productive securely. I saw Jaren was raising his hand, actually.
It's pointing.
Oh, thank you. We're in the back there? Yeah, so the question was the testing process for going through this. I work in QA, so I can answer it from that side, but I want to hear how the Threat Labs handles these things.
Yeah, so you're right. A lot of it comes down to VMs, but VMs present an interesting conundrum because even medium strength malware is essentially like looking for VMs. So a lot of these malwares launch, and like the first thing it does is, am I in a VM? And if the answer is yes, then it doesn't do the thing it's going to do. And so like that makes it tricky to, you can get in under the hood and you can, mess around with the instruction set and stuff like that. But like obviously that's going to be really tedious and time consuming. So one way that we work around this is that each of us on the team uses like a Mac Mini that's just like dedicated to detonating malware. And like it's not connected to any of our company resources or anything like that. And so...
And a lot of lengthy conversations with legal and InfoSec to make sure
Yes.
that they know that what we're up to and that
Yes.
we're not going to get fired for
Yeah.
doing the things that we're doing. Yeah, preparing for our presentation, we had to do the same. We're like, hey, Dino, we're going to be compiling malware. Please don't fire me.
Yeah.
And yeah, making sure that the device isn't connected to the corporate Wi-Fi, making sure that you are not putting your personal Apple ID or your, company Apple ID on there. Like just being as smart as you possibly can when you're testing is really important.
My Mac Mini is kind of like that favorite T-shirt that you like don't want to wash too many times or whatever, and like I should just screen record
unlucky.
it because it's like there's so many weird things going on it where like the calculator just opens itself every 30 seconds. I don't remember why, so it's a minefield.
Awesome. Give it up again for Matt. We are out of time.
Thank you.